Hello. Hey everyone. I'm Zain, CTO of Horizen Labs and ZK Verify. Welcome. Today I'm going to talk a little bit about how AI agents can achieve trustless autonomy. It's ZK Verify's guide to on-chain negotiation. I'm excited to be here. The broad strokes that I'll go through are this backstory, the trust gap. I'll also talk about ZK Verify's case studies. The first case study being ZKML, the second case study being agent identities. And lastly, we'll summarize and have some next steps. First, a little bit of a backstory. You've seen a lot of the talks, panels here already talking about AI agents. The space is growing by a lot, and this ecosystem map is already out of date. It's already a magnitude bigger, and we're seeing agents everywhere. Not only is it in volume, but in terms of market cap in $1 billion, it's even from 2024, we're in 2025 now. It is a segment that's growing very quickly, and many of us know that. But I want to put a little bit of focus here on A16Z's most recent crypto report. It's from last month, October 22nd, and it talked about how crypto could solve many of AI's problems. The first one that I'll focus on is really around what is human and what is not, and also with all these agents having identities for them. So there's not only proof of humanity, but also proof of non-humanity. It is a key requirement to agent not a negotiation. And then we've seen a lot, the previous panel talk about X402, and this is just bolstering the case that crypto is the only viable, is maybe the only viable payment rail. So as agents multiply and work together, there is this trust gap, and that's a prevailing theme in the talks today. Whenever two agents interact, like the ones shown on the left, whether they're talking to each other, building something together, paying something, we are starting to see that the end user is no longer human. The end user are agents, and agents will initiate transactions, manage balances, and negotiate amongst each other. With all these billions of autonomous agents having transactions with every second, how can they interact without human insight? And that's where ZK Verify comes in. We're working to close this trust gap amongst agents, and I'll go through the two quick use cases around ZKML, which is broken down to inference and training. Inference is all around whether the agent has run the inputs that they said it would in the way that they said they would. And then training is about whether the model has been trained on the specific data. And then around agent identity, we want to push for a world where agents have a unique identity that's based on its internals. What is ZK Verify? ZK Verify is a blockchain that we specialize specifically on verifying proofs at scale. And the zero-knowledge proof lifecycle is about creation of proofs, aggregating, and then finally verification. We focus on the verification side. Why are we doing this? We believe that it allows developers flexibility where they don't have to think about the proof types and writing verification code. There are new proof types that are coming out all the time, proofs that improve on previous proofs, proofs that are specialized for certain things, such as databases. And so we don't want developers to worry about that. We want to be the enabler for continued innovation, and it's also around cost efficiency. We want to specialize in a layer so that we can bring cost efficiency to verification, and we want to have verification results available for all different chains. So ZK Verify in a multi-agent world, we picture agents to be negotiating with each other, to be interacting, and we want ZK Verify to be the universal verifier for the agents and their interactions. It's also a tool that we can embed into agent workflows. This is ZK Verify right now. We are mainnet. We also have our testnet. We've verified a little bit over 6.8 million proofs. And this is our dashboard, some of the proofs that we support. Gross 16, Ultra Blanc, Ultra Honk, SP1, RIS0, FLONK, Plonky2, Proof of SQL. And so I'll just go into two quick case studies on how ZK Verify applies to agents negotiating. The first one is around ZKML. We heard about Coinbase Agent Kit 402X. And then identity. This is another view of the case studies. We view ZKML as this like base that allows us to build on top of it. It is the base building block for trust and where AI, verifying what AI is doing. And then above that, agent identity. So first, agent negotiation and ZKML. We've heard a lot about this. This is Coinbase's agent kit that was released quite a while ago. It enables agents to interact with each other through the blockchain network with wallets, on-chain actions, and that flexibility. This also shows that agent-to-agent payments are already underway through their interactions with each other. And I know in the previous session we talked about micropayments with AI agents. This is the 402X protocol, which allows for better payments to happen on-chain. It's much cheaper. The average fee is way lower than credit cards, and finality is faster. These are some trading agents alive and well in the world right now. Krill 3, using algorithms and deep learning. We have also ASCN.ai and Shrimpy, and it's growing more and more. And so I want to talk a little bit about ZKML. It stands for Zero Knowledge Machine Learning. It really is around the two things that I mentioned. On the bottom is proof of inference, that the agent has produced a certain output given the specific input data. So this proof is generated each time that a query is requested, and it keeps input data and agent's internals private. And then on top of that, proof of training, that the agent has been trained with specific data. This is an example of agents negotiating. On the left, we have a user agent with various holdings, such as Zain, VFY, ETH, and their accepted risk level is a level 5 out of 10, let's say. And what do they want to do? They want to work with other agents to get their job done. This agent manages the user's portfolio and wants to do it on a specific risk profile. And so that agent can choose between other trading agents after this ZKML proof has been verified. And and you'll see that each of the agents are producing that proof verified by ZK Verify. And once that's done, we know that the two agents are roughly equivalent, and the user's agent can select based on the cheaper option. Right now we have EZKL, which is a proof of inference type. It's available on ZK Verify. Play around with it, and we're excited to offer it. Case study 2, I'll go through negotiation and agent identity. There's been a lot of research here around agentic AI and identity framework that shows of a more rich identity, identities that are based on naming services, what their characteristics are, advanced cryptography. And a simplified way of viewing this is to say, hey, same example, and this agent now not only wants to verify that the other agents have that proof of inference, but we also want to select an agent that has reputation, one that has a specific identity, that has been around for a while, has history. And so with that proof, the proof of ZK AI ID, then the user agent can select the right agent based on their credentials. So those were 2 really quick use cases. And just to summarize, that was the A16Z State of Crypto. We addressed 2 areas. It was around identity, agent identity, and then payments. The alternative view as the foundation of it, and how ZK Verify is influencing the multi-agent world. Come chat with us. We have a booth in the back. These are some of the things that you can reach us through: our website, our GitHub, our docs, and our socials. Thank you. Questions? All right, thanks everyone.